Awesome. Hello, everyone. Welcome to a new learning session. And let's go ahead and let's get started. Um, so launching a parachain is a really, really big task. And there are a lot of steps involved and many, many different things to consider, such as what are the different launching options and what makes most sense to you? When should you get your runtime audit done? How do you go about writing safe code? And what components should you include at your initial launch? Do you need pseudo governance? How about a full-blown staking mechanism? And then there's also the idea of auctions on Polkadot. How do you win auctions? How do you actually onboard to Polkadot? And so much more. So where do you start in this journey? Well, this is what we are going to cover in the next 3 Polkadot Deep Dive sessions. We are hoping to take you from ground zero and provide a path for you to launch your own parachain. From tips to prepare beforehand, writing the first line of code, to making a live parachain, to making and managing a live parachain, and more. So join us in these next 3 sessions to learn how to launch and manage your own parachain. So what are we actually going to talk about in today's agenda? First thing is we're going to talk about why should you become a parachain on Polkadot in the first place. Then we're going to provide kind of a roadmap about kind of the different decisions that go into actually launching the parachain. Going to cover some options to deploy. And then, of course, we're going to talk about actually preparing. We're going to prepare before the code, what code components to include in your parachain, certain details that are smaller but need to be thought about, and actually preparing for auctions. And then, of course, we'll talk about actually deploying, winning auctions, and do a full demo of onboarding a parachain on a local testnet. So without further ado, I'm going to pass it over to Joshua to talk about why you should become a parachain on Polkadot.
Sorry. Yeah, thanks for that. I just wanted to highlight earlier again. So many of these sessions you've definitely covered have shared a lot about how you can use Substrate and the power of the pellets and its modular architecture to build a blockchain. But really, it all comes together when you become a parachain or when you connect to Polkadot in the future with Parathreads. Essentially, becoming a parachain has 5 key benefits. A parachain, firstly, is a sovereign blockchain. What that means is you have full control of all your custom palettes, and you may even employ different types of tokenomic design that may not even have transaction fees, or you may have full control over how you can subsidize transaction fees. In some cases, you may want a smart contract blockchain. In some cases, you may build a dedicated app chain. So it's really the world is your oyster in terms of designing your fully sovereign blockchain. Secondly, it's industry leading in terms of the ability to share the security of Polkadot to all the parachains. So when you're a parachain, you essentially leverage the economic security, which today stands for more than the market cap of more than billions of dollars, attached to every parachain. What that means is using validation, proof of validity. All these blocks on Parachains essentially have these proofs committed on the relay chain, which is Polkadot. That means your security is as strong as the economic security of Polkadot. The third thing is upgradability. Now, this is something that already comes with Substrate that you do not need to hard fork. What that means is that your upgrades, and even and you will be able to see it even in deploying a parachain, that the upgradability comes in really handy, where the upgrades to runtime can be within the next blocks. Whether is it through pseudo in its initial phase or through governance, what this means is that communities who partake in the activities in your blockchain can bring upgrades into the next blocks and allowing your chain to continue without hard fork. Another key super important thing is that with all the value that the tooling of Substrate brings, common things like Polkadot.js, wallets, and common fundamental building blocks of the pellets are all for your use. Now, what about services? So essentially, things that become services like DeFi, implementations of stablecoins, they are also within your reach when you become a parachain, as long as these other ecosystems evolve around Polkadot. What that means is that you can focus on what you want to build most in your project instead of reinventing the wheel and building all these key primitives of DeFi and so forth, when really what you're trying to do is to test a certain use case. And all this comes together with consensus message passing. So what that really allows is for your ability to have messaging across, but more importantly, in a way that is secured and trustless for interoperability. Because each of these parachains, as we mentioned earlier, share the same fundamental security that Polkadot secures over the entire ecosystem. Every message through XCMP has that same level of security and consistency as a message. So that really makes it groundbreaking in terms of its ability to become a situation where you could do massive amounts of network effects as you build different technologies within our ecosystem. So the road itself isn't very different from building a blockchain from scratch. To be honest, becoming a parachain essentially is about becoming a fully sovereign blockchain. But really what Polkadot and Substrate allows is for making this process almost as seamless as you can ever achieve with such a technology. So there are multi-dimensions you always have to take note of. What we usually cover here is mostly about tech development, but definitely there are areas like your product development, funding, marketing, and team hiring. And across this decision journey and design, you would start to realize that you will pick up different skill sets along the way. Now, for such a big and long, complicated map, what we really want to focus today is the areas in pink, which is really what's unique about Polkadot and the ability to become a parachain. So specifically things like the ability to be on one of our key testnets, Rococo, the ability to do crowd loan auctions or direct bidding, and so forth. So one of the things we definitely would recommend before you dive deeper into code when you're thinking of your project is to really start registering yourself. So there's a few key areas that definitely would help you understand what's going on, when's the next auction slot available, and how do you become a parachain. So one key area definitely would be to join the Matrix chat room called Polkadot Direction and Matrix Parity.io. Another key thing is that to understand about all these slots of auctions, they are essentially run by governance through Polkadot. So definitely keep your eye out for it. So over here, I've shared these motion. You can find it either on Polka Assembly or Subsquare. I'll give an example for Polka Assembly. So essentially, there's an ongoing motion that's right here, in fact, released just yesterday on the next available parachain slots in which you could potentially bid for and become a parachain. So at the starting point, just keeping aware of the calendar would be a good place to get your mind in the game. Then the second thing is, if you want to review the actual schedule itself, it will be directly within the auction schedule. And how that would look like is essentially something like this. If you follow the link, where you could just visit the different auctions, and it would tell you roughly the dates in which the bidding starts, the bidding ends, and the auction starts, and the entire availability of the lease period in which your parachain can be live on. So just getting your hands understanding the dynamics is a first key step. And also another quick question, but it's mostly a business question. As we mentioned, this is going to be a multi-dimensional project, thinking of business, funding, and development. Another quick question that you have to answer is whether is it going to be a situation where you directly bid for a slot on the Polkadot auctions, or is it a crowd loan? Now, it's very important in such a step that you think about if it's a direct bid, you need to do fundraising early, usually to investors or socializing your project to VCs or angels, such that you secure the funds you need to already be in a position to get a slot. Another key step definitely is to start talking to auditors in advance, such that you have a good sense of what they expect when you build your prototype into a stage where you could go into an audit. So these are just quick basic things that hope to get your mind initially in the game.
And another thing to think about is there are actually a lot of options to deploy. So what is actually, what are these options and what might make the most sense for you? Now, these are just some of the options that we decided to cover here. And the first one is the simplest, cheapest, and quickest way, which is just deploying a smart contract. And you can see here, Ink is the kind of substrate native WASM-based smart contract language, and that's Squink, the little mascot. And this is, like I said, an easy option. You don't have to run your DevOps and run collators and get everything up and running like that. You just have, a couple files of code and you upload them to a chain. Now you can do this on parachains that have Ink available, or if you'd rather, we do also on Polkadot, there's also parachains that are EVM compatible. So you could deploy Solidity smart contracts on there. But moving on to full chains there's the idea of deploying a solo chain. And by solo chain, we mean it is not connected to Polkadot. It does not have any shared security. So all of the security needs to come from your end on your solo chain. And then once you are ready, you can always migrate to a parachain later. Now, moving on to the next option is this one is, it's not commonly used, but it is an option. It's called a seedling runtime. And a seedling runtime, what it allows is essentially to be a placeholder runtime. It's sometimes used for solo chains to migrate to parachains, but it can also be used in the sense of, say you are wanting to win a specific auction slot, but your runtime is not ready yet. What you can do is you can win the auction with a seedling runtime. So it'll just be a placeholder that sits there, and then you can prepare your full runtime and then do a runtime upgrade from your seedling runtime to your full runtime. Now, the option we recommend the most is to just go a native parachain route. So prepare everything in advance, like Joshua was talking about. Think of the steps ahead. Think, what auction do I want to win? Start preparing your funding, whether that's through crowd loans or direct bids. Prepare your audits way in advance, and start building your runtime right away. So that way, when you get to that specific auction you're trying to win, you can have everything ready and you go to win the auction and you just deploy your full runtime right away. This is the option we recommend. Now, moving on to the next slide, we actually talk about some of the things that you should put in your initial launch. Now, the first thing we recommend is to start simple, because like Joshua said, Substrate is super powerful in the sense that you can do runtime upgrades very easy. So you don't need to worry about jam-packing everything in your first launch with as much as you can because you're afraid you don't want to do a hard fork. You don't have to worry about that in Substrate because you can do forkless runtime upgrades. So start simple, get something out there that is still secure, but get something out there so that you can start. And then you can start adding on complexity later by doing runtime upgrades to add little bit by little bit. So maybe you've got a specific palette that you're building, you can add that in, do a runtime upgrade, and then that is available in your blockchain. Now, we do also recommend starting with sudo. Of course, decentralization is super, super important to us, but we do recognize the benefits of starting with sudo at the initial launch. Now, the reason for this is it just allows you to prepare and make sure everything is running smoothly, and your runtime upgrades, you can do those, and there's less chance for your chain to basically be inaccessible. Like, you cannot upgrade it if, say, your governance breaks. So you can use sudo to then perform these runtime upgrades. And then when you are ready, once you feel like you have a decentralized enough and secure enough technology, such as a full governance that works super well, then go ahead and remove sudo. And like I said, you can remove sudo through a forkless runtime upgrade. We also recommend start with a small governance. This can be optional, but start with a small governance that's it's just simple and it's small and has some key stakeholders or some key people that you can trust to actually test this out. So test out the small governance and make sure that, for example, the runtime upgrades work. You can perform a runtime upgrade through governance. And then if you're confident with this, use your governance to remove sudo. So it's still a little bit centralized, but it's more decentralized. And then start adding more components, like I said, and move to fully decentralized when you are ready. And then also collator selection, and use collator selection instead of a full staking mechanism. So collator selection is collators basically talk to the validators on Polkadot. So they're essentially validators on your chain, but they have to sync up with the validators on Polkadot. So collator selection, it selects the collators that will actually produce the block. And you can reward them. For example, you can take your fees and put it into a pot for the collators and reward them for producing blocks. It's not as secure as a full staking chain, but we recommend starting here because as there have been attacks with staking chains where there aren't enough people staking the currency, and then the chains are attacked. So start small and secure, and then move to more decentralized as you grow your user base. Now, moving on to the next slide, these are just some of these small details to think about when preparing a parachain. So one of them is your total issuance. How much tokens do you actually want to release to the ecosystem? Whether this is a million or a billion, that is up for you to decide. How many decimals do you want your currency to have? So this could be like 12 decimals, where you have 12 zeros following, a 1. So that's one currency or one token. So you should decide on that as well. It could be 12, 18, however many you like. But then also there's a lot of things to think about with your fees. First, are you charging too much or too little in fees? Are you going to burn them? If you are going to burn your fees, how much of that do you want to, say, put in the treasury? Because you can configure all of this. Do you want to have 80% of the fees go to a treasury? You can do that. 80% go to treasury, 20% burned. These are all things that can be configured, but are important to think about. First off, to keep your chain secure, but also add features like funding the treasury, kind of how Polkadot does it. And then there's also the idea of benchmarking. Now, benchmarking provides the weights, and the weights provide how much the fee costs for a certain transaction. Now, there are default weights built into Substrate, but these are likely built on different machine specs than you are going to run. So figure out what your collator machine specs are and actually run all of the benchmarks for all of your pallets on that specific machine. So that way your weights and your fees will be specific to the machines that you're actually running them on. So it's a super important piece just to make sure everything stays as reliable as it can. And then, of course, the last step that we're talking about here is actually preparing the release. Now, there's a super cool tool. It's called SR Tool, and it's a Docker container that builds Substrate. Now, the super important thing with this is that it allows for deterministic builds. So that means when you do, for example, a GitHub release and you post, here is the WASM hash of our runtime, and it's built with SR Tool. So somebody else can go, they can build that same runtime with SR Tool, and they can verify that the hex encoded calls and the hashes are in fact the same. So that way, if somebody's doing a runtime upgrade and people want to verify that they are doing the runtime upgrade they say they are, they can verify it with SR Tool. So that's a super important piece that should definitely be used. And Frank will actually be doing a demo of doing a runtime upgrade and kind of comparing the hashes with SR Tool to make sure that it is the right runtime. And then lastly, there is the chain spec that you need to prepare. Chain spec is an important piece that provides things like what are the boot nodes, or what are if a new collator is onboarding, what are the nodes that they should connect to be able to talk to the rest of the network. But it also contains the genesis state of your chain. And this genesis state has to be agreed on by every single collator using it. So usually you share this chain spec to all of the collators, and they all must agree on this genesis state. So that way, like I said, they're all in agreement. And moving on to the next slide, back to Joshua.
Thank you. Yep. So definitely now the assumption here is that you're at a stage where you've gone through many of the substitute tutorials. You've built up through the node template, the basic substrate node template. And if you customize a couple of palettes, and you're in a stage where you're very confident with your POC, it may be a solo chain, some basic solo chain that you're happy with, may not be in the productions, just a test net, and you're happy with that. Now, at this stage, you're very certain, you're committed, you probably have a GitHub repository, you probably have a couple of people working in a team. It's time to actually get down to business. So the three key things I think should be definitely on your mind. Firstly, to reserve Para ID. So what you would go to is this link itself basically goes to Polkadot.js, and you just click to create a Para ID. And yeah, from there, one of the key requirements is minimally you need approximately 100 dot itself to be able to do the process. So I'll just quickly just want you to see the page. So yeah, reserve deposits about 100 dot. Yeah, and this ID would be yours. So quick place to get started. Another key thing that you definitely need is the SS58 registry. You need to submit particularly a particular prefix. Now, definitely as a user of Polkadot wallets and Polkadot.js, you will definitely observe that every time you shift from one parachain to another, you've noticed that your addresses change, but essentially they all come with the same account, same set of accounts on your wallet. You have the same seed phrase. So what essentially is doing through the prefix is it's generating a whole new set of addresses. So one other this key area would definitely be important to be able to generate those wallet addresses on your new parachain. And then definitely another area is the Polkadot.js apps endpoint registration. So in this link, I shared an example of Water and how Water has included themselves. So essentially, when you go down Polkadot.js, you see Water. The reason it's there is through this pull request in which this information has been added. So yeah, at this stage, when you're committed, definitely someone within the organization that's reviewing this pull request would review it and see that you are actually committed to the ecosystem and building something that's relevant. And yeah, as soon as that's the case, you get all these going. And now, once you have all that, and the next key thing is definitely with that prototype on a basic node template to turn that into a Parachain node template. So what we do is they take all the components of the runtime and put in the Parachain node template. Now, as we mentioned earlier in the general map, you're currently at the stage where you would like to test it again on a relay chain testnet. You may have already done that on a local relay chain, and definitely in doc substrates .io, you would have a tutorial directly on that. But now, how do you actually get onto Rococo? Essentially, it's also a tutorial on doc substrate, which I definitely would love to share with you. But there's one key area that I definitely, a lot of people going through this process have not realized in advance, but I would love to share with you. So yeah, if you go to this tutorial itself, running through it, you would be able to, earlier we talked about things like a Parachain identifier. Similarly, in Rococo, there's a similar process to register it. Of course, that means that you would go to the faucet and get the relevant Roco tokens at the moment, be able to register and modify and just follow this tutorial along. Now, the area that I definitely want to put more emphasis on is the expectations on the ability to test your Parachain on a place like Rococo. Rococo as a relay chain for testing is nonetheless similar to Polkadot. It is fundamentally also restricted in its ability to just onboard just get everybody. So what we would do is either to administer both permanent and temporary slots for Parachain slot on Rococo. So in general, I would say permanent slots, as highlighted here, permanent slots are typically assigned to teams that have at least completed the slot lease option on Polkadot. Now, if that's not you, if that's not the case you're going for, then definitely a temporary slot on Rococo is going to be a situation for you. So what that will mean is it's dynamically allocated in a round robin rotation fashion. Now, how that would work essentially is you submit a Rococo slot request. You can find it within the link in the document, but essentially you would submit it to support, and yeah, and then from there you'll probably get this round robin temporary slot. So yep, back to the rest of the presentation. Now, the other key thing, now that you're in this time period where you're looking at connecting to Rococo, you're very close to being ready and confident in your runtime, is to go through the runtime audit. Now, the best advice I would say is, instead of just relying purely on auditors, one key document that I would love to share with you is a document on unsafe and insecure patterns. Thanks to the benefit of hindsight, we've looked through 30, 40 different parachains, helping to identify different areas to catch on things, best practices, or things that we know that people might be challenged with. Essentially, we've come up with a document highlighting things like error handling, unsafe math, and things like unbounded vex as some of the key things to watch out for as you're building. But yes, with that in mind, then you would go and ensure that you are talking to auditors early. Now, there's a tendency to give this an afterthought as you're building, especially when you're in your prototype phase. But really try to do it, especially in times where things can get a little bit busy for auditors, preferably months before, and asking for availabilities. Now, you would also probably definitely ask them for exactly what kind of requirements they might expect from you. And one way to also think about which auditors is to review the past parachains that are successful and their associated audits. That can be helpful to actually understand which auditors are more reputable, which ones will be able to help you in this journey. But yeah, if you need a recommendation, don't hesitate to reach out to us. But like we say, these are not endorsements. It's just ways that we connect you to the relevant teams that can help. Yep. So now, when you're in the phase of an auction, now this is when you have something that you're confident with. You've tested on the local relay chain on your own. You've done some form of Rococo testnet connection, and you are confident in your POC becoming a parachain. You would then open a crowd loan or direct bid. Now, this is a key area in which I would love to share with you, and quite often it's not fully well known, but it's in the documentation itself of auctions and crowd loans. So very similarly, things like the registration, the parent ID, the exact parameters of what you should be able to put into place for the Parachain slot auctions. Specifically, either direct bidding or crowd loans are directly here. Now, this is the time maybe I initially glossed over direct bidding versus crowd loans, but I just want to highlight to you that you need it's a general these are the two potential areas that you can definitely think about winning your Parachain slot. A crowd loan essentially is the ability to lend the power of the community, where the community is able to essentially use their DOT and commit to your project and lock it along with your commitment, and that sum itself in totality will be the potential sum that will be able to outbid others on their project to win that same Polkadot Parachain slot. Now, the trade-offs for such an implementation, naturally, based on what we observe with the industry, is that teams and projects tend to give an incentive. Now, that incentive may come in terms of certain types of assets on your chain, and this may range from NFTs that you might give in a retroactive way, or in terms of incentives to the native token or whatever token that you think would incentivize them to do these crowd loans. Now, that would mean that trade-off is essentially potentially diluting your tokenomics, but you can also see it from another perspective, which is increased participation from existing Polkadot holders into your community. So essentially, it becomes not just an ability to achieve a parachain, but it also is a business decision on your part. Now, when we talk about doing it instead of crowd loans, you could potentially do a direct bidding. Now, with direct bidding, what that means, and I mentioned it earlier, is that you would be able to commit a large amount of thought on your own to be locked in to the Parachain slot during the duration of the lease period. Essentially, what that means is that you will need this relatively large amount of capital that you can put aside. So quite often in such scenarios, that will mean that your ability to do fundraising out of the platform, the ability to have the sufficient amount of thought, is entirely, once again, a business decision. How you're able to raise this outside of this particular ecosystem could be through venture funds, could be through private investors, could be through other ways and means. But essentially, there is, once again, trade-offs. That is a business decision. Now, either both approaches will work, and in different time periods, we've seen it being implemented depending on a bull or bear market. So depending on what you see, what I would suggest is take a look at the past auctions that have happened, take a look at the strategies they've employed, and that's a good way to think about what you want to do with your chain. But ultimately, I just want to emphasize, this is mostly a business decision. There are trade-offs, and there will never be a good one-size-fits-all. Yep. A few other considerations I just want to highlight is consider this other area within your runtime of a remove lock function. So definitely, if you go to this particular pull request, you will to understand and read through what the remove lock function is. But just to highlight, in the past, we've observed one crowd loans, especially, is a very particularly important execution. Now, in the case, especially with crowd loans or direct bidding, you make a mistake. As we all know, with everything in blockchain, this can become a problem. So the remove lock function, actually, before you do anything before it becomes an actual parachain, before you actually win the slot, you're able to use this function to actually change that bid or change that submission if you've made through the crowd loan. What that essentially means is that you could actually start making some changes in case of mistakes. So strongly recommend this in the runtime. The other thing, which is also, once again, another business decision and consideration, is, as I mentioned earlier, for example, direct bids might be potentially for your project too expensive. But if you look at Kusama at this stage or at certain stages, it might be relatively cheaper. So considering things like deploying Kusama first, enabling a pilot, doing more testing, adopting more community members before actually considering the migration to Polkadot might be a good solution or a middle ground solution to help you achieve your project. Other things I would say about tokenomics, really, tokenomics is a huge, huge topic. But the area that I think definitely deserves some conversation on or sharing on is tokenomics specific to Polkadot, unique to Polkadot. So as I mentioned earlier, with crowd loans, you do have to think about what type of the potential incentives are in place to allow the contribution for community. Now, apart from that, if you're doing a crowd loan to win the current slot, you must also think about your future the sustainability plan for future slots, in which what we call slot lease extensions. So if you're doing one crowd loan right now, what about the second crowd loan in the future for your lease extension? So what that would potentially mean is the ability either to continue to collect tokens or continue to collect certain rewards, or allocate a certain distribution over multiple slot releases, lease extensions, and to make sure that that is already planned for in your overall tokenomics design. Another question definitely is collated, and the question of collated staking. Now, to be very clear, based on the design of Polkadot, collators is essentially a minority assumption. As long as you have one truthful collator, the whole Parachain system works. Essentially, in terms of its source of truth, but that will never really be totally enough. Essentially, it's good to have a collection of collators that's sufficiently large enough to be able to collect all the submissions of transactions across your chain. Now, what incentive do you have that collators continue to collect transactions at a reasonable pace? So although collateral staking is entirely optional, but it's definitely a general idea to think about in terms of incentivizing the infrastructure of these essentially collator nodes that collect transactions to then be able to commit it to the relay chain. These are essentially, once again, business decisions, because staking requires incentives and rewards, which once again, you have to think about. Once you've done all that and you're in the auction, you have a crowd loan or you have a direct bid. Now, how do we know whether you win? That's a good question. Now, what Polkadot has done is that we know the perennial problem with auctions. So essentially, if all it did was win on the final block of the auction period, essentially people will all be holding on to, especially if they're doing a direct bid, they'll essentially be holding on to their dot, not even submitting a transaction until the very last block, essentially creating a situation where an economic world, it's imperfect information. And that's not what we want to achieve. So how Polkadot solves this is through essentially what we call the candle auction winning criteria. So there's essentially a starting phase and there's an ending phase. As the start of the ending phase, that's really when we start keeping score. So every block from the start of the ending phase to the end of the auction is keeping score in terms of who has the most dot or KSM that is relevant to be able to win that Parachain slot. Now, but that is not enough. What essentially a candle auction does is it picks, using VRF, a random block out of this entire ending phase as the block to make its final judgment. So in that particular block, if let's say you are the particular Parachain submission that has the highest amount of dot contributed or highest amount of dot being bidded on, essentially you win. So what that means is there is always a chance if someone has outbid you at any one point of time, although he's done it less times than you, there is always a chance he could win. And so it's entirely based on the randomness of VRF and which block gets chosen. So once again, take a look at this, and you can definitely review past case examples of chains that have won despite, being at the end of the day, they were not the ones with the highest contributions, but just by the luck of VRF, they have achieved it. So take a look at this and understand the mechanics, and hope that manages your expectation. Yep. Once again, as I shared earlier, things like the auction schedule is available for you to take a look at. At this point, the governance is going through its motion to be able to release the next set of slots for this year. So do stay tuned on the auction schedule for this to be available. Yep, and with that, I think we have time to share it with Frank, who will be going through the deep dive demo.
Excellent. Thank you, Peter and Joshua. So just before we jump into the demo, I've just got one brief slide just to kind of explain the different components that allow us to kind of run through the demo. So on the left is just what we need to kind of get up a local relay chain. So we're relying heavily on ZombieNet, and that allows us to, through a configuration file, actually configure or specify the exact network requirements that we need, obviously using the Polkadot binary. So in this example, we're going to be looking at Rococo Local. And as part of that ZombieNet process, what it actually does is it reads in the config file, and then it generates out a chain spec file. And we're going to need that file to then pass into the collator to launch that, so that our collator knows how to connect to the relay chain. Then over across on the right, we've got the Parachain template. And I've kind of made a very small modification to that. I've just taken the existing runtime that you get in the template, and I've just sort of cloned it or split it into two, just so I can sort of demonstrate the upgrade process. So the initial runtime, all that is it's just the existing template where I've added in the pseudo palette and I've removed the template palette, and the upgrade runtime is just the default runtime that you'd expect to see. And over on the right, then we've got the SR tool for the deterministic builds that Peter introduced earlier. And you can then see that that's going to generate out the initial.wasm and the upgrade.wasm files. And we're just going to use GitHub Actions for that. That's all been pre-built just for the sake of time. Then beneath that, we've also got one additional tool, which is called subwasm. And all that's going to do is allow us to actually interrogate those WASM files that we download, just to make sure that everything checks out and that we're happy with it before we actually then use them to launch the chain or upgrade the runtime. And that then eventually results in our Parachain running below with Alice and Bob as our collators. So in terms of the actual steps that we're going to follow through is launching the relay chain, which is a quick command. We're then going to reserve the Parachain identifier, as Joshua outlined. We're then going to quickly prepare our chain spec from the binary, make a few modifications. We're then going to prepare our Parachain collator, launch that, and then finally register the Parachain. And then once that's up and running, we'll go ahead and upgrade the runtime. So I'm just going to switch across now to my development environment and then just bring up my notes. So before we jump into that, you'll just see that I've just got two Git submodules. One is the Polkadot, building the Polkadot binary, and then the other one is the Parachain node with a slight modification. We just drill into that very quickly. You'll just see here is the GitHub runtime, the build runtime, GitHub workflow. And within that, we're just building out the initial runtime and the upgrade runtime, and that's using the SR tool, GitHub action. And then there's a summary step, which is essentially just outputs the results of the whole process and sticks them in as a file so we can easily download them. And then if we also then just check into the runtime folder, you can see there's the initial runtime that I spoke of, as well as the upgrade runtime. So, and then one last thing is just the ZombieNet configuration, which is very simple for this example. So you can see the chain is Rococo local. The default command is just the Polkadot binary that we built earlier. And then we've got our three different nodes, and that's effectively it. So first step then will be to launch the relay chain. So I'm just going to copy in this command. So essentially we're just using ZombieNet spawner network, passing on the config file above, and then the -p parameters, the provider, we just say native because we want to run the native binaries. So I'll kick that off, and that's essentially now going to spin up the Rococo local testnet. Now, as part of that process, ZombieNet, for the sake of ease, we're just going to quickly copy that chain spec into our working folder, just so that it makes further steps much easier. So we need the Rococo local raw file, copy it into our local folder. So you can see now your Rococo local appears, and that is the chain spec for the relay chain. You can kind of see that everything is just got the key value pairs all hex encoded. So that's good to go there. So the next thing is to actually now connect to our chain. So I can go back, launch a new tab, and then connect to our relay chain. So you'll see now that we connected to Rococo local and is currently producing blocks. So we've got our relay chain running. The next step that we're going to do is to reserve our parachain identifier. So if you go into the network section, Parachains, Parathreads, and then click on ParaID, you can then see, as Joshua outlined earlier, we can then start to reserve our ParaID. So we're just going to select 30, accept the default parachain identifier of 2000, and then the reserve deposit of 40 for this particular network. Click Submit, sign Submit, and then just go to the Explorer and wait for the events. So you can see here that it's been confirmed that we've actually reserved our Parachain 2000, that's owned by 30, and obviously the 40 tokens were reserved. And if we were to deregister, then obviously we do get those tokens back. So we've now registered our Parachain identifier. So the next step is now to start focusing on the Parachain side of it. So if we go back to our environments, we'll just clear that out. So the first thing that we need to do is to build our chain spec. So what we can do is just run this command. So you can see it's in the substrate parachain node, which is the submodule. We're then using the actual binary parachain template node, and we're using a subcommand called build spec. We're not worried about boot nodes for the sake of the demo, and we're going to output that into a plain chain spec. So if we run that, you can see it's been built, and it should appear here. So what we're going to do now is we're just going to modify this file based on our needs. So obviously we registered Parachain 2000, so we need to set Parachain 2000 here. You also see that the chain spec includes things like balances, and the collator selection, as Peter mentioned earlier. If we then just scroll to the top, there's 2 additional changes. We need to set the ParaID there as well. And then finally, we'll just give this Parachain a name. So we'll just use launching a Parachain, just to use a unique value on the network. So once that's done, we now need to generate our raw chain spec file. So very similar command, you'll see it's exactly the same as above. The only difference is that now we're specifying which chain to use, specifying our plain chain spec file, and that we want it to be a raw output. So we'll run that. You'll see the new two collators appear for Alice and Bob. And then if we have a look at the raw chain spec, you'll see now everything's been hex encoded and imported into the chain. So we've got our chain specs prepared. Now we need to actually prepare our parachain collator. So as I mentioned earlier, the actual runtimes have been built out using GitHub Actions. So what we're going to do is just quickly download those. So if we just go to the result of this GitHub action, and we go into the most recent run, you'll see at the bottom there's 2 different artifacts, there's the initial and the upgrade. So we'll just download the initial, open that up, and you'll see within there, there's all the different WASM files, and we're just interested in the compressed version because it's the smallest. So I'm just going to copy that and go back to my development environment, and then just paste that back into the working folder, just for ease of use. So they can see it there. Okay, so now that we've got a file locally, we just want to actually validate that file. So if we then use subwasm, as I mentioned, using the info subcommand and passing the name of the file, we'll then see that it provides some metadata and more importantly, some hashes. So what we can do now is we can just go back to the GitHub action for the initial runtime and then look at the summary. And this would be the actual output of the actual command when the SR tool runs. What we're going to do is we're just going to take some of these hashes and just verify that indeed it matches up. So that's the proposal hash. Then we've also got the authorized proposal hash, which is in effect the same step. And then most importantly, if we scroll down within this output, you'll see there's different runtimes. So that the compacts relating to the compact WASM, but we're interested in the compressed one. So compressed Blake 256, take that hash, and then we just kind of quickly then lastly just verify that that matches. So all good to go. So the next step then is actually to generate the Parachain Genesis state. So one last command. So again, we're using the Parachain template node. This time we pass in the subcommand of export Genesis state, passing in the raw chain spec one last time, and giving the name of the file as the last parameter. After running that, we'll have additional file that appears, and looking inside it, then that's the Genesis header for the Genesis state. So we've got all the sort of smaller components that we need now. The last thing that we can do is actually go ahead and launch our collator node. So this is a much longer command, and I'll just take you through each of the parameters before we actually launch it. So again, it'll be using the same Parachain template node binary. We're specifying Alice as the collator, so it's going to use Alice's dev keys. We're going to run it as a collator. Force authoring just allows it to produce blocks if we go online. Offline. We specify the raw chain spec that we want to use. The base path is just where we're going to be storing the data on this local machine, the obvious ports. The additional parameter that allows us to use the SR tools is WASM runtime overrides. So we're just specifying a location. And what it's going to do is when it launches, it'll look at that location for any WASM file overrides. And you'll see when it runs, it actually finds the one that we downloaded and allows us to use that file in its place. Then the remaining parameters are the parameters that are used for the embedded relay chain node. So you can see there the chain spec is a Rococo local raw JSON, which we took from ZombieNet right at the beginning. And then there's one final little manual thing I need to do here is I just need to change the port of the boot node as per the port that ZombieNet has allocated. So each time ZombieNet kind of runs, it can allocate a new port just to avoid port clashes. So we'll just paste that one on there and then run the command. So you'll see there, let's scroll up slightly, we've got this Parachain found WASM override, and it's actually picked up the initial runtime WASM that we uploaded. So it's obviously going to validate to make sure that the encoded chain spec and the binary and the whole WASM runtime and everything else matches the resulting WASM file to then accept it before it'll actually launch. And then one last thing to check is to see relay chain. We've got 3 peers, so we are connected to the relay chain. So now we can just go to the actual interface of Polkadot.js for the Parachain, and you'll see that effectively we are stuck there waiting for blocks to be produced. So nothing is going to really happen until we actually register this Parachain using the reserved Parachain identifier on the relay chain. So to do that, we'll switch back to the relay chain, and then we'll go into developer, sudo. We'll select para sudo wrapper, and then sudo para initialize. So this is going to need a few parameters here. So the first thing is obviously our reserved para ID. We're then going to select some of the files that we generated. So the first one is the Genesis head, which is in this Genesis state file that I opened up and showed you. Then it's the actual WASM file itself, which is used for the validation code. So we'll select the initial runtime WASM file. And then kind of importantly, we need to select yes here for the parakind. Effectively, no maps to a para thread, yes maps to a parachain. So once we've added all that in, we can then submit that, sign and submit, and we'll just monitor that. And looking at the events, you can see there in block 93, we've got PVF check started with the hash and the parachain ID, and then second to that, PVF check accepted the hash and the parachain ID. So we've submitted the registration has been accepted. If we now go into the Parachain section, you'll see para threads, and you can see there that the onboarding time has got 1.5 minutes to go. So I might have run through that a little bit quickly. In prior runs, it was down to about 30, 45 seconds wait. So it's a good opportunity for me to have a quick sip of water. Okay. Hopefully in the edit we can kill this dead air. Okay, so it's obviously disappeared now from the para threads. If we then switch across to the overview screen, you'll see there that's a parachain, starts having sort of gray and then comes white as it comes online. And if we then switch back to the parachain, we should see that we are now producing blocks. So in essence, we now have a live parachain and people can obviously start submitting transactions. The last portion of the demo is just going to be to go ahead and actually upgrade the runtime. So if we go back to our outputs of our GitHub run, back to summary, and then we just go to the bottom to our upgrade runtime, download that, open it up, and then this time we want the upgrade compressed as previous. And again, we're just going to paste it into our working folder just for convenience. And then you should be able to then see we have our two different runtimes. The initial one that's already live, and the upgrade is the one that we're going to use next. So we've done all our prep for this. One last thing that we want to check is the actual hash. This time I'm just going to look at the Blake2 hash of the compressed file, which is that there. So we'll just copy that and then go back to our Parachain. So to upgrade it, we'll just go to developer sudo and then Parachain system. And this is kind of like a two-phase process. The first bit is authorize upgrade. So we could just paste in the hash that we've just generated, A23B4F, or we can choose hash a file and select on that upgrade runtime. And then if we check it, you can see that obviously that matches. So we submit that, go to the Explorer, you'll see upgrade has been authorized at block 6 with the same hash. Then the next phase thereafter will be to go sudo parachain system, and this time we actually want to enact the authorized upgrade. So if we then choose the file, this time obviously we want the upgrade compressed WASM file. We open that, submit it, sign and submit, and then just wait for the events to appear. So we see there we have the parachain system validation function stored. And then if we then switch across to the actual relay chain, we should then see two events appear, which is this paras PVF check started with the same hash. Oh, let me just clear that. Same hash. And then second to that, the paras PVF check accepted the same para ID and the same hash. So it seems to be accepted. If we now go to the parachain section, you'll see the status is now changed to upgrading. And we've got sort of 12 seconds to wait, plus an additional on the other side. And it's going to be done at block 145. So while that's running, you'll see here Parachain identifies template Parachain 1, and that should obviously then change to 2, which it just has. If we flip back there, you can see the upgrade is completed. Nothing else in terms of events. But more importantly, if we just zoom out here slightly, you'll see now if we go into the developer section, sudo, it doesn't work because sudo is actually being removed. If we then click into the extrinsics, you'll see there's no sudo palette because of the default runtime for the Parachain template doesn't have sudo. But more importantly, template palette has appeared. And then just to conclude, we can just quickly submit a quick transaction using our upgraded runtime and then wait for the event. And there we go. So 42. So that's effectively showing us the whole process of sort of onboarding a Parachain, submitting the deterministic runtime, and then upgrading the runtime to add functionality over time. So just sort of switching back to our slideshow to conclude. So that concludes our demo and the first part of the Parachain series. So be sure to join us next week to continue the Parachain journey. And we'll conclude on the final slide to say thank you for your time. And if there's any questions, please drop it in the chat. Thank you very much.